So this is the Checkly webinar on open source observability with OpenTelemetry. And Checkly, we said Checkly twice, but there you go. This will be a generalist piece, especially for those of you who are thinking about what are your open source options for adding some basic observability in your system. It'll cover the basic concepts involved, the design goals, and other requirements. And yeah, we got a lot of attendees. That's fantastic. Again, feel free to pop a hand up if you have questions. I'll make a few pauses throughout, but I will try to answer questions as we go through it. I have the Q&A open here. So yeah, we should be able to do that. All right, let's go ahead and jump in. So what is observability? Now, on the West Coast of the US, observability has been synonymous with a number of tools for quite a little while. The further you get from the Bay Area, the less observability becomes the term that people use. You can see terms like monitoring, you can see terms like APM, which generally I understand to be a more limited part of that scene. But there you go. Let's talk about that definition. So, observability is our time to understanding of a problem. So, this is the Voynich manuscript, possibly the thing with the longest time to understanding in history, where we still have this is a medieval text that we still do not have translated into any recognizable form. And if you'd like to know why that is, go ahead and message me on Twitter at serverlessmom, and I'll talk to you about it because I do know what the Voynich manuscript is and why it was created and what the text in there means. As do a lot of people. It's just my pet theory about its interpretation. But so usually time to understanding is the first half of our mean time to resolution, right? We have to understand a problem before we fix it. Now, back in the day, when we were manually restarting our servers, there were definitely times when you had memory leaks where the solution to that memory leak was to restart the server, and you don't know why it's leaking memory, right? You don't know what line of code is doing it or what function is doing it or what's causing it. It was just happening, and there wasn't a lot of understanding at all. So it is possible to have a fix without understanding, but without understanding, our stress level gets a lot higher, right? Because we don't know. We're going to go back to bed. I'm going to use the example over and over again of like an incident response scenario where we know that there's a problem. We have users reporting a problem. We're trying to fix it. We're trying to go back to bed. If we don't understand what caused the problem and okay, it's working again, right? Our sleep for the rest of the evening is not going to be very peaceful, is it? Right? Because we are going back to bed thinking, okay, I have no idea when this is going to reoccur or why. So why do microservices make this story significantly harder, the observability story significantly harder? And this is one of the sort of disruptive ideas I've been pushing for a little while, all over this industry, where it really is true that observability is a tougher nut to crack than it was maybe 10 years ago. And the short version is that microservices, that the monolith, for all of its vagaries and problems, did have a better ability to fully understand a problem that was occurring on that monolithic code base. So if we ask a question like, if this component fails, what will happen, right? On a monolith, usually the answer is everything breaks, right? But it was an answer that we could get pretty easily. A huge problem with monolithic code bases, with truly monolithic code bases with very high interdependency between every single component, is that only very few people had any understanding of the system. And in a bad shop, in a shop with a lot of tech debt, almost no one did, or no one did, right? But once you had debug access, once you had good control of the stack, and once you had good understanding of your code base, right, you could see any related variable, any related component. It was all in one place. And so it was quite a bit more observable. And in the microservice world, this is just an abstract drawing, so apologies, but someone does understand each of these dots quite well, right, in this interconnected microservice architecture, but nobody fully understands the map. Now, when I say that, sometimes people are like, no, I understand my microservice architecture. And I'll say, I alluded to it before, but if we take one of your microservices down, if you have more than 30 or 40, if we take one down, let's say we take one version of one down, what will fail and what will work? And I think for most of us, the answer is we're not 100% sure what's going to happen as a result of that, right? So it's not that we don't understand the system or it's just a huge black box or anything like that. But the fact is that we are in a situation where there is a little bit more chaos and there is a little bit poorer understanding of what is happening inside that system. And so when we have an outage, I think that's usually when that lack of understanding comes to the fore, where we're saying, oh, we really don't have a good track of what is happening inside this system, um, and how it might be failing. I talk about all that. I talk about microservices because that is really the argument for OpenTelemetry. That the OpenTelemetry is about trying to improve the observability inside of a microservice architecture. Before we step further into OpenTelemetry, are there any other questions that people have? Is there anything I can answer about this first little bit? And go ahead and just either throw a hand up or drop something in the chat or the Q&A here if you have questions. Okay, folks, fantastic. Let's get on to the next piece. There are a lot of components in OpenTelemetry, and we'll talk through what those components are. But one of the things we really want to be aware of is that the collector, the OpenTelemetry collector, conceptually is where a lot of the magic happens. As I think a few of you do know my bio, you know that I've worked with multiple people who are entirely, multiple vendors who are entirely focused on OpenTelemetry. And so I fielded questions with the community where they say, well, do you support does this tool support X framework? Does it support this device? Does it support this? And my answer was always the same. If you can get that data into the OpenTelemetry collector, then yeah, sure. The rest of the tooling will work. The collector is where that magic happens. And so if we look at this conceptually, with OpenTelemetry, we want all this data flowing into this collector. So stepping back just a little bit to say what is covered within the OpenTelemetry project, this diagram really helps illustrate what's going on and what are the main components of the OpenTelemetry project. There's some other edge case, we'll talk about that, but actually this gives us a pretty good model. One big component of the OpenTelemetry project is the OpenTelemetry collector, which could be described as a data middleman, where it may or may not be running on a separate service. It may be running on your own network, but it's some place where all data is getting sent in for OpenTelemetry. OpenTelemetry data can go to a third-party service without a collector involved. That third-party service is probably running a modified version of the collector. Another component, the one that most people have heard of, is that the OpenTelemetry project includes instrumentation packages for multiple common languages and instrumentation projects for Kubernetes, for shared infrastructure, other components that can be instrumented with OpenTelemetry project instrumentations. Those will gather the performance data from inside of your application and then send it via the OpenTelemetry Transfer Protocol, or OTLP. I guess just OpenTelemetry Protocol, sorry, not OpenTelemetry Transfer Protocol. But and that is the formatting that data gets passed into the OpenTelemetry collector. Another source, right? You can go write your own instrumentation and transmit it via OTLP to the collector, but these are really big components. And then the part that is not covered, and we'll talk about this more later, everything that happens after that collector, that is where the data is stored and how the data is displayed to you, is not part of the OpenTelemetry project. Okay, stepping back to what are the three pillars of observability. I'm not going to spend too much time on this since we joined to talk about open source observability. So quickly we'll step through this. Let me just get my notes caught up here. This is Kandinsky's three pillars. Apologies. This appears to be the highest resolution on the internet of Kandinsky's three pillars. At some point, I'm going to go to New York and take a picture of it that I can drop in here. So, right, first we have our signal of metrics, right, which is just a count of something happening. Metrics are a highly compressed format for transmitting telemetry data because they can include things like averages. They can include really easy aggregation. Can we get the PowerPoint after the presentation? Absolutely, Syed. Yeah, this will absolutely be shared. Also, a video of this presentation will be available on the Checkly website. I'll send that out as an email to all attendees. So both the stack and just the raw video of this will go out to you. Great question. And yeah, very, very easy to store in high volume. Obviously, right, any metric can hide things, right? I've seen many examples where internal services were failing. So a metric which shows our response time got a lot better because instead of when someone requested records, instead of taking the time to go and find all those records and come back, and so your response time is 10 seconds, it was every time someone requested was responding almost immediately with an error message, right? And so that was, hey, great, our response time's way up, we're doing great. So metrics obviously have the ability to hide problems in their aggregation and synopsis tools. So logs, right? Logs always have a complete thorough explanation of the problem somewhere, right? Storage and management are their own problem, are their own trouble. Now, in OpenTelemetry, there are three paths where we get logs. And if you look at the OpenTelemetry page on logging, there's actually a lovely statement on there which says sort of the vision of the OpenTelemetry project is not fully expressed in logging currently. So right now, OpenTelemetry is just adding the ability to send logs from their instrumentation libraries. So while it's very easy to make calls to add spans to your traces and to create metrics from within your Java application or your Python application with the OpenTelemetry project SDK, sending logs was not natively supported until very recently, which is kind of a surprise. You think, well, don't you really need logs? But remember that logs also, you already have almost certainly a pipeline for logs in your system. You have some way to send your logs out. So the advice was up through most of 2023 was, hey, just connect that existing log pipeline to the collector. And so there's no need to send it some other way. Now, this is right, the three signals, logging, tracing, and metrics. And we'll talk about tracing in just a moment, since this is the most basic one to the project. So what the logging page of the OpenTelemetry homepage says is, these are these three channels of data, and they're all working, but right now they're not connected. So in our vision for OpenTelemetry someday, they're going to be a sort of braid where almost every log is connected to a trace. Almost every metric is connected to a log or a trace. And again, every trace says, here's the connected logs, here's the connected metrics to this. Now, conceptually, that's not perfect, right? Like if you're reporting an average response time metric, it's not necessarily really connected to any single trace. But right now, those connections are not as implicit as the board would like. So that's an area of growth for the OpenTelemetry project. Notably, this is out of date by a month or two. Logs are listed as experimental on some of these, but again, remember that you probably already do have a pipeline for logs. So you really, I at one point said, when I think it was like the Ruby project looked like this, like, traces are stable, but metrics and logs not yet implemented. I was like, well, geez, the Ruby project's not ready for prime time. Now Shopify is using the Ruby project like in production, right? So clearly this is something that is working in production. So this is it's a very late stage for something to go over to stable in this sheet. So don't get too hung up on this. This is from the OpenTelemetry homepage, framework support page. Okay, so finally, let's talk about tracing. So informatically, tracing is a hybrid between metrics and logging, and it tries to generalize observed time spans. So the goal, and here's an example from the Datadog interface, the goal is for this, very pretty sort of waterfall chart that shows the spans of time that are being consumed by a particular request. So the dirty secret here, and I'll actually read slide text, which I don't always do, so I'm sorry about that. The dirty secret is that most trace data is never viewed, and by most, that means something like 3/9 of data, like a huge chunk of trace data is never viewed. It's a very a dense amount of information. It can be more informatically dense than logging, and needs must, right? If you're storing a trace on even a small percentage of requests to a production site, and you really have to look at individual traces to get a sense of what's going on, most of those traces, the vast majority of those traces are never going to be viewed. So questions about that before we move on into distributed tracing? Nice. Okay. Again, go feel free to throw up a hand mid presentation. I'll happy to take a look. So tracing is all well and good, and I think some of us, when we look at this tracing chart, right, we think about what we used to see or what we still see from like the developer view within a browser, right? When we're controlling the virtual machine that a browser is running in, we can see all of this data of every single request and every single process that's happening in a page load on the front end. But when we talk about the back end, tracing has become quite a difficult concept. And by the moment of inception of the OpenTelemetry project, the OpenTelemetry project grew out of open tracing, which was just this observation that it was getting very, very hard to see where a request was going. When I was working at an APM vendor, we had this very cool way to measure individual time and code requests on separate microservices, and it was passing through and showing you those aggregate times. Very, very cool stuff. The request we get all the time is, don't show me all that data. Just show me where a request is going. Show me what services are being hit. And we go back to that question of, okay, what services would degrade performance of this kind of request? I just want to know for this kind of request, what services are even seeing that request. And so, if you're in that situation with your cluster or overall service architecture, I think it can feel a little lonely and feel like, oh, we're the only ones with this level of tech debt where we can't fully, know even the path of every single request. It's common. That's a common situation. So, OpenTelemetry existed at first entirely to create a really, really good way to do this kind of tracing, to see each request coming in being handled, by an API in and out, and reporting some information from each microservices, even as it travels between applications. And the collector has a role here much bigger than just translating data formats. It does a lot more than just exporting that data. The collector, let's see, how are we doing for time? We have time to talk about this. So we'll come back a little bit to touch on distributed tracing just a bit more as far as how we view it informatically. But let's talk about the role of that collector. So I think it's natural when we think about all of the data that we can collect with these instrumentation libraries, how we can collect data from multiple components. And obviously, a huge piece of our tracing ability, right, is that context propagation to be able to send context throughout. Very, very cool. But we start to think a little bit about, okay, this is starting to be a great deal of information that we're gathering. And I don't just want to send that over the wire to some service to store all of our metrics. Even if I'm doing it locally, even if I'm paying very little for storage, I'm just still concerned about how that's working. And so this is where the collector becomes a very key part of the story. So this is a visualization of what the collector does, right? It has its receivers, it has processors, and it has exporters. And receivers and exporters are sort of the things that we would expect, right? Is that, hey, it can accept data in multiple formats. It doesn't just have to take OTLP data, and it can send data to multiple places. So the OpenTelemetry project is definitely not, I mean, by definition, is not at all picky about where your data is going on the end. Again, that back end is not part of the project. So let's talk a little bit about data cardinality and one of the concerns that we should have when we're just sending data without any kind of processing within. So let's look at this high cardinality data. So in this case, we have data about response times. We have some like analytics data that we're sending on this table, a number of hits, how many new they are, the time on site, their particular value that we're sending for these metrics. This is a complex object that we're sending for each of these requests. Now we have this label here on this object, this key value pair of page, and then a particular page, and this looks pretty good, right? We're able to aggregate pretty easily. We can Later we can go back and maybe filter and say, hey, which user ID was making the, a particular set of requests. But we have nice aggregate data on the performance of individual pages, their percentiles, that other information. And we're able to get from that some really nice, right, page performance stats. We're able to do a lot of processing and come to interesting information on what is the overall value of a particular page load, what is the cost that it reflects to our infrastructure, that kind of thing. Now, let's look at data that is the same information, but in a format that is much, much less useful with a single change. So instead of having a key value pair that gives the user ID as one of the attributes of this metric, now the path for each page includes that user ID. So this is a surprisingly common situation when gathering request data. And I'll tell you something, from our top level, this does not look that much different from this table, right? As we're looking at single metrics being reported, we're like, oh, cool. Yeah, no, I do want to know what user requested this page. But our ability to aggregate this data is almost zero now, right? We can't say, hey, how is the known issues page performing? And you look in this version, we had information on a whole bunch of different pages on this single page, right? On this single sheet of our metrics. We're able to get really views all the way across our system. Now all of the information is just on a single path, just showing it for multiple users. And when we try to aggregate across metrics, right, no aggregation is really possible. All we're going to see is the average performance for this particular user ID. So the good news about this, and apologies for just throwing a block of code up, but we'll step through it briefly. I promise you're not going to have to run this code yourself. This is our preview of this. The good news is that the collector has a pretty extensive ability to do some aggregation and crush some of that explosion of metrics. So one of the things that can be a little bit confusing about this, not to step through these same slides repeatedly, is that the term high cardinality data, whether or not a particular vendor defines high cardinality data at a particular threshold or not, and whether or not they recommend sending high cardinality data will vary. So cardinality in this case is the number of possible values for a particular attribute. So this, I would say, has pretty high cardinality. We have a lot of pages that are being observed. We may have hundreds or even 1,000, I suppose, at the outside, a possible, page paths here. Let's say we have a blog, a long-running blog, and a long-running social site on our page, right? We have a lot of possible values per page. This version has quite a bit higher cardinality, right? Because it's a combination of every single path plus every single user ID. Its cardinality is basically infinite, right? It could have millions of possible combinations here very, very quickly. So it will vary whether or not some vendors are saying, hey, you should only really be measuring performance for 2 or 3 metrics here, right? Maybe you should just have, instead of looking at every path, you just say, hey, was this a request to the marketing site or was this a request to the actual, service pages, user pages? Well, that's just going to vary whether or not that's defined as high cardinality or this is. And a lot of that is going to have to do with what the underlying engineering that provider has done to display and aggregate metrics. Nobody is going to recommend that this is the right way to do it, that this is the right table to send. But what they do recommend you do is going to vary. And so, for example, one provider, Honeycomb, is very into high cardinality data. They want to see every possible metric value. They don't want severely crushed metrics. That is something that their data backend really excels at. Okay, so the collector, thankfully, has a great ability to do some crushing of this data. So we can give it, this is a config file for the collector, which is able to find values and crush them down. And again, we're not going to step through this code as what it's exactly doing, but you can preview a little bit that it accepts some settings about, hey, we want to drop these particular keys, we want to keep these others, we want to simplify others, etc. So our first principles here, right? OpenTelemetry instrumentation, like any code level instrumentation, lets you send a lot of data rather easily. Some of that data is noisy, some is sensitive, and some is good but needs tweaking. When faced with a data collection problem, it would be ideal if we could solve it without having to commit any code changes. So this is kind of a critical thing, and this is going to be our bridge to talk about check lead towards the end of this presentation, that one of the things to be aware of is that a great number of us who are tasked with measuring performance, uptime, the overall performance of our system are unable sometimes, but often not encouraged to have to repeatedly tweak our actual code base to get these metrics working. And so it's a pretty common pain point to say, we're not getting the metrics that I like, and I'm going to keep stepping back to this, this bad table here. This is not great, right? When we're seeing this in whatever backend we're using to see our metrics. But even worse is realizing, hey, I've got to call up the product team that works on this area of the product and that install this instrumentation and ask them to tweak those settings at the code level. And that's like, oh boy, I wish I hadn't do that. Because for example, your code level instrumentation may be saying, okay, send the complete path, with all attributes up to the collector. It's reported as an OpenTelemetry metric. So obviously you could at that point at the code level say, hey, I want to change this and start removing any attributes or removing some attributes or something like that. As you see the data come back, you're going to want to tweak it again. And so this is often just organizationally not a great relationship, because it's very unlikely that those product developers are really in this metrics observability backend all the time. So they're not going to be that jazzed about repeatedly having to tweak it. So ideally, we'd like to do this without having to commit any code changes. So in this example, at the code level, we've added some instrumentation to this code to report up to OpenTelemetry. Now, again, automatic instrumentation is available, so this is not something that we're going to have to do for every single request with OpenTelemetry, but there are reasons that we want to add stuff manually. But one of the attributes we sent was a database key. And so that's maybe not that great to be sending up as an OpenTelemetry attribute. They're completely unexpurgated database key. So what we'd like to do is we'd like to fix this without having to ask someone to go and change the application code again. One of the things about the OpenTelemetry collector that we haven't discussed yet is that it's very possible to have multiple collectors connecting with each other. This especially matters if the connection between the service and the collector is particularly far, and we're concerned that it's going to take a long while to transmit that data. And so we'll see this connection here, where we'll have multiple collectors that are then reporting into kind of a master or collector, whatever you want to use, to send it. I didn't mean to use the term master. I should say a main collector or a central collector. Now, one of the great advantages of being able to filter data at the collector level is that as you have an implementation like this, you can go and modify the settings on a single collector and affect the appropriate services with that kind of filtering. Some of the filtering that's available in processors, right, is scrubbing, data normalization, batching, and sampling, right? You can say, hey, I only want to send 10% of all traces. I want to send them at a minute cadence and not make a send every single time. And then the two that we really care about here, right, are both scrubbing data and normalizing data. So another thing you can do at the collector level is you can say, hey, these two services are both encoding user ID, but slightly differently. We can go ahead and normalize that. And so you can add attributes that you want to see or ignore. This is back to seeing another filter list. Now, some things to remember about filtering, right? Once a span has hit an attribute that will filter, and a span is, right, any component of a trace. Later conditions won't be checked. Conditions are chained, so any matching condition causes filtering. And if all span events for a span is dropped, that span will be left intact. So even if you remove all the events from a span, and if you drop all data points for a metric, though, that metric will not be reported. And last thing here is that these filters are chained and they just are read from left to right. thinking a little bit conceptually about tracing, the actual implementation process for distributed tracing looks like this, right? We add a new trace header somewhere close to the start of the request, and that's done by instrumentation libraries and OpenTelemetry that have a good sense for that framework where a request is starting, right? If we think about Elixir or some other common web framework, it has a really good idea of, hey, I'm handling a new request now. It passes that around with the request, and then there's collector side logic to tie those traces together. Remember, our goal, right, is this kind of trace looking view. And the idea is that we have really good context propagation within the project. And actually, there's been some pretty impressive implementations recently that do neat stuff, security stuff, testing stuff, other stuff not directly related to observability by adding a little bit to that context propagation that gets sent around. Okay, questions about tracing, filtering, and those components of the collector architecture? See, I time these pauses to get my water in, folks. So, what can't OpenTelemetry do? So that's not a zero list, right? So OpenTelemetry is specifically not covering the backend receiving and displaying of OpenTelemetry data. So in tutorials, in demo examples, you'll see open source tools that are used for this, often completely DIY, which has their own drawbacks just implicitly to how that's implemented. Um, that you're running, if you're running your own storage data, you're running your own dashboards. First of all, you have some lift with that DIY, but also, of course, you have the issue of the system that is supposed to tell you when you're having problems with your overall system is being run on the same basis. So you'll see people who want to use a completely open source solution for storing data in dashboards, doing things like going to a second public cloud to run that backend so that it's still working even if the rest of their system isn't. This also includes notifications and finally synthetics, right? About looking from the outside to see how our system is performing. So there are a lot of options for that dashboards and storage component. You can look at CoreLogix, Chronosphere, Honeycomb, all have really full featured responses to, hey, we will receive OpenTelemetry data and we will display it for you. Now, you may notice that the big two of APM or two of the big players in APM are not listed here, even though every single big APM vendor does say that they will accept OpenTelemetry data and display it in a dashboard. I have some writing out there that you can go find to talk about why Datadog and New Relic are not listed here as top level options for receiving and displaying OpenTelemetry data. Datadog especially has a very checkered past in their relationship to this project. Outside of the scope of this talk, but that's why they're not listed in this list. So when we think about this component of synthetics, about looking at a page from outside, going in and checking it, and maybe even simulating an update to, simulating a user request to that page, a synthetic user request. One of the things to think about is how far that kind of synthetic check can go. So one thing to be aware of with OpenTelemetry is that both synthetic user monitoring and real user monitoring are not currently part of the project. I think real user monitoring, it may be that in the upcoming 5 years, you will see that as part of the OpenTelemetry project. But synthetic monitoring from an external site is really not a likely part of what the OpenTelemetry project is going to cover. So the OpenTelemetry project's choice not to include a standardized project for receiving data and displaying it was largely a decision made not to compete directly with the Datadog and CoreLogix and Lightsteps of the world, and instead to work with those vendors and say, hey, we will send data to you and you will display it to the users. The thing is that it is from that external data storage and display standpoint that you would want to run pingers, site monitors, and synthetic user monitors. While it may not be a great idea to be sending your logs and metrics to just someplace else on your network to display performance data, since that could go down at the same time that your service does, it is completely not workable to say, hey, from within my own architecture, I'm just going to go ping my architecture. And if that's working, then great, we're up, right? For two reasons. One, obviously, when they both go down, and you don't receive notifications that anything's going wrong. Further, we very often have situations, right, where pings are successful to our service from within our service, but that is the only place that they're successful from. So it just doesn't reveal that we have problems if we're just pinging from within our own service. So you need to have some kind of external service to do that. So way back in the day, right, that was Pingdom was like the only game in town for this. And then later, some external services were created. People will use open source solutions for that. But this is where Checkly comes in as being an incredibly full-featured solution. This is a screenshot of a Checkly interface that has an incredibly a full-featured solution to doing that external monitoring. And right here, you see displayed some of the monitoring as code features, which show not only that we have this test, that it's running, here are the results, but hey, this particular check was updated at this time by this person, and you can monitor it directly next to your other code in your code base and commit to it as well. And go ahead and feel free to drop questions in the chat. I want to make sure that we get through the last of our slides here in the next 7 minutes in our time slot. So going to go ahead and roll right on. But again, if you ask questions here, I will see them. Okay. So what do we do? Originally, as I mentioned, you know what, folks? I said, hey, drop questions. I'm going to go right ahead. But during that question pause, that's when I drink water, which I need to do. All right, back on. So what do we do with a very complex flow? So we talked about how a very basic, site pinger might just say, hey, when we went to this URL, we got a 200 response back. But we've all had outages where that's not giving us an accurate view of what's going on, right? People are logging in and seeing login failed. People are trying to do some site activity. It's not working. It looks like the classic, right? It's a 200 OK response where the message is, I have run into an error and cannot fulfill this request, right? So we want to go a little deeper than that, but what do we do about a very complex flow? So here's an example from an API, a banking API, right? Where we want to set information for our initial session setup. Then we want to go into a particular piece of the user flow. We want to get a flow configuration, and then we want to go ahead and handle authentication details or something else, obviously, right? There's multiple steps for a connection with a banking service. So when we look at those kind of really complex steps, that is often in the realm of what others might call synthetic testing, where we say once in a while, maybe once at deploy time, we'll simulate this very, very complex flow of what's going on, of what we should do on this page, including things like logging in, doing account actions, undoing those same, adding a listing, going and deleting that listing, and seeing if the results are correct. What Checkly does, we call those same things synthetic site checks, because we're able to run those frequently with this same level of detail. So what you're seeing at the right here is some config to do a very complex action within this banking site. And this is playwright code to go and send a complex ID value, including like some authentication details that are stored as local environment configuration, and get back that data and even act on that data. So, given this response, act on it in the following way, and then do a deep set of tests on that. So in this case, we're checking an account balance and we're expecting it to be greater than or equal to a certain value. So this is a really, really complex flow that is able to be simulated by Checkly. So Checkly's monitoring as code lets us code up that test, run that test locally, right, from our own machine, and say, okay, this is passing, or this is the response that we're getting back, and then deploy that test again right from working next to our code base, right, write our TypeScript tests, and then deploy them, and have that deploy history be just as visible as any other source repository where we're able to see when the test changed, what's going on with it. If we suspect that a change in the test is what's causing it to suddenly fail, we can see that source control information on it. And there's even deeper sophistication here, like visual regression testing. So this is looking at some feedback within Checkly to say, hey, we have a problem with this site because it looks dissimilar enough from a previous screenshot of the site, and getting this nice feedback. So this is in part enabled by Playwright. Very, very strong component of what Checkly can do to monitor your page. Now, of course, right, a lot of people do associate this with, once a week or once a deploy testing, right? It's like, okay, only when we deployed, we need to check for visual regressions. But how many of us now have sites that really implicitly rely on a number of third-party services? How many of us now have sites that allow people who maybe don't have product access to modify things on the site with something like Google Tag Manager and implement arbitrary JavaScript on the site, have live changes of little banners and social widgets and other components on our site? This visual regression testing just can monitor constantly or continually, certainly, the page to check for. I don't say constantly because it's not every millisecond, right? You're able to set a cadence to do those checks. So able to write synthetics, write JavaScript or TypeScript, get clean notifications and escalations. And of course, this works even when your system isn't working. Oh my gosh, folks. 8:45, very nearly on the button. 8:45 my time, very nearly on the button. Feel free to drop any final questions you have in the chat or into the Q&A. Go ahead and come and visit us at Checkly HQ. My name again is Nočnica Millifera. You can find me almost everywhere at serverless_mom, on GitHub at serverless-mom because they don't allow underscores. But otherwise, folks, I really appreciate y'all joining us. It's been great to see such a great list of attendees. To those of you who are watching this recorded later and received a little invite to come and check out the video, feel free to join us on the Checkly Slack, which you can find our community Slack down at the bottom of every page at checklyhq.com, and look for weekly updates from us on our Checkly blog. Folks, thank you so much for joining us. I'm going to leave the chat open for just a minute, but otherwise, I really appreciate y'all taking the time. All right, thanks so much, everybody. I really appreciate your kind words in the chat. This was a fun one to do, a little information dense, but we will. Jorge Padilla, great question. What is the relationship between OpenTelemetry and Checkly? So Checkly is actively exploring good ways that we can integrate with an OpenTelemetry ecosystem. Right now, what Checkly does is fill a role that is not covered by the standard OpenTelemetry project. So synthetics checks, external pings, and heartbeat checks for your API are completely uncovered by the OpenTelemetry project. So using, for example, OpenTelemetry with, say, CoreLogic's backend is a very powerful way to monitor your site's internals, but Checkly is a way to cover what that solution will not. So that sort of presents a complete observability picture of your system. So great question, Jorge. Thank you again, by the way. You've always been a great participant in my webinar, so thank you so much for coming out again. But yeah, great question. It is much more about the two together forming a complete observability picture rather than them being terribly integrated currently. But yeah, in some way that's surprising, but I actually think that this makes a pretty critical design, right? Is that from within your network, from within your architecture, you absolutely can do open telemetry monitoring, and get really good views of how your traces are connected to logs, that other stuff. And you can use open source tools, store that data within your own network and preview it from within your own, view it within your own network. But you really want a completely external service to monitor, both do heartbeat checks and do synthetics checks of your site from the outside. And you really don't want to have that connected on that chain. So maybe I'll introduce a slide about that the next time I get this talk. But yeah, that's sort of the idea, is that they're really, it might be an extremely good idea to have kind of a separation of church and state there. That maybe it's okay if your site is completely down, that yes, you also can't check your logs or check your metrics that are generated from within the site, but you still want to access something like a Checkly dashboard to say, hey, what's going on from the site externally? How long have we been down for users? What regions are we down from? Those kinds of pieces. Okay, great. I bet that's our final question. Really great question, Jorge. Thank you so much. Um, but yeah, folks, now we're past 8:45, so I'm going to close it up. Again, you'll get an email, if you registered for this,